We'll now go to OAuth Top 10 2013. The first one is injection. The attack vector is easy. The prevalence is common, meaning there's a widespread occurrence of that. Detectability is average and impact is severe. So in the event injection materializes, then the impact is going to be severe. So what is injection? Injection means tricking an application into including unintended commands in the data sent to an interpreter or sent to the server. Interpreter is, it takes strings and interprets them as commands like your SQL, OS shell, LDAP, XPath, Hibernate. So all these are kind of things. How attackers do it? First, they find a vulnerable site. So once a vulnerable site is found, they type in the SQL statements into the text boxes, maybe to the URLs, or even inject them into other form fields using request manipulators. Example is say Fiddler or Burp Suite. And then once the SQL attack vector is gathered, now once they find out that there is an issue, they give different statements. Say, for example, for the database version, for gathering the actual server name, maybe select at version may give you the database version. At server name will give you the actual server name. So if it's a Microsoft, they may give select at Microsoft version. So a list of other servers, all user accounts, or select start from some user database. So different SQL commands will be injected in the form fields or in the URL to cause this issue or to exploit. This is a simple authentication query where SQL injection is being attempted. Select user ID from user data where username is something and user password is something else. So if you see the URL on top, some unsafe application, login.do, user equal to and password equal to some encoded value is put. So this is how a simple authentication query actually goes through. From this, you can actually insert certain statements to see whether any error is happening, whether the system handles the injection properly, whether filtering of unnecessary characters are done. This is a simple SQL injection example. If you see in the URL, you will see after login.do, user equal to inverted comma or 1 equal to 1. So basically they are trying to do a authentication bypass SQL injection and password equal to 1, 2, 3, 4. So select user ID from user data where username equal to the SQL or the authentication bypass string and user password is 1, 2, 3, 4. If you want to learn more about the commands that are to be put in SQL or for XSS or for that matter authentication bypass, there are a lot of cheat sheets available on the net. Hackers.org is one. So you get ready-made attempted scripts for you to use. So you can, while doing your assessment of your own server, not with permission, you can attempt those commands or those particular scripts which you get ready-made from the site. OWASP also has a cheat sheet where you can download it from the OWASP site to test the applications for SQL injection. So this typical impact for SQL injection is it spy out or manipulates data, manipulate the database server or access the underlying operating system, bypass authentication or gain administrative privileges. So these are the impacts of a successful SQL injection attack materializing. Then correlation with information leakages. Attacker uses error message or codes to verify the success of an attack and gather information about the type and structure of the database. There is something called a blind SQL also. If the error messages don't help the attacker, he can still take a stab in the dark or a poke in the dark. The normal application behavior, that's the response time, might give away clues on successful or failed injection attempts. Now, many of the commercial tools detect SQL and blind SQL very fast. Now, my experience is whatever the tool gives you, also whether it is open source or a commercial tool, try it out on that particular field or particular place where and see whether it is actually materializing. There may be a lot of false positives also that the scanners may give. So it's always better to try out a particular injection on a particular field to just confirm that it is actually happening. This is again taken from some cheat sheet. Typical SQL injection attack patterns for bypass authentication. Some of it is listed here. The others you can download from the internet. You can just Google the cheat sheet for SQL injection. You will get a whole lot of resources. Now the typical SQL injection attack patterns are: one is spying out data, where you use union select command, manipulate data is updating, and manipulate the database server itself is executing some kind of command shell or format C. So some of the syntax and the commands, the patterns of how the SQL injection attack happens is given here. You can you can download the cheat sheet and try it out. The best ideal way to learn is you download a vulnerable application. There are at least 30 or 40 vulnerable applications which are there on the net, which you can download as a VM or install, and try out different possibilities of WASP top 10 and other vulnerabilities. So those applications are intentionally made vulnerable so that the user can learn, or the candidate can learn on how actually the exploit happens and what were the commands that were used for the exploit. So it gives a better perspective on how to secure and also how to do a proper assessment of a web application. What is the protection for SQL injection? Avoid the interpreter at all if possible. Use an interface that supports bind variables like Java SQL prepared statement or Hibernate parameter binding. Enforce the principle of least privileges for the application's database user. Perform whitelist input validation on all user supplied input. Now you should always implement server-side validations to prevent the attack. The fundamental thing you have to learn in a web application is you can never trust client-side validations, as anything that is installed locally on the client side can be subverted or circumvented or bypassed by an attacker. So they can also see what you are checking for if you are putting a client-side validation, which will give them even more information with what to attack. So the input must be validated, all inputs must be validated server side. This is a very vital rule since website attack originate from the client, such as a web browser, and data that it sends to the server cannot be trusted. So attacks like your SQL injection, cross-site scripting, and many other vulnerabilities can be thwarted or can be secured by adhering to a very simple rule: do not trust client-side data. We'll see whitelist versus blacklist validation we mentioned in the previous slide. Whitelist is a positive security rule, that is, block what is not explicitly allowed. Example, allow only small a to z, capital A to z, and 0 to 9. You define once and then almost never worry again because it is already set. It can be quite effortsome to define for a whole application, but still you have to define it once. Now, there is a negative security rule or blacklist. allow what is not explicitly blocked. So you have to write down parameters which are blocked. So whatever is not there in that list only will be allowed. Example, the hash, the semicolon, inverted colon, in HTML injection, greater than less than sign, semicolon, script, inverted colon. So it can be bypassed by masking attack patterns must be updated for new attack patterns. Now a lot of this can be encoded and actually be put in the URL. Also it can be masked so that that particular input is not recognized by the server so that the validation will not happen. So it's always better to go for a positive security rule and enforce that in the application, even though it will be difficult one time. You set it up and then there can be a peace of mind. Remember to always sanitize your database input. This is a very famous cartoon which has been going on as a SQL injection example, which is used by almost everybody who talks about SQL. Now, this is a scenario. The mother gets a call. So, from the other end, the party says, "Hi, this is your son's school. We are having some computer trouble." So, the mother asks, "Oh dear, did he break something?" So, the school responds saying, "In a way, did you?" So, school asks her, "Did you really name your son Robert inverted comma drop table students?" That's the name. "Oh yes, little Bobby tables we call him." "Well, we have lost this year's students record. I hope you are happy." And the mother responds, "Yeah, and I hope you have learned to sanitize your database inputs." So this is a very nice cartoon of how SQL injection can happen. And in 4 little cartoons, it says that you have to sanitize your database inputs before it is stored. Then we come to A2, which is broken authentication and session management. An example of this is given here. In this example, you see the password retriever. You have forgotten your password? No problem. Just enter your email address and the postal code below. Click retrieve button. Your password will be displayed on screen. An email with your password will also be sent to you. Please make sure the email address entered is same as you used when you created your TopBuy account. So for your security, please change your password after you get out of the old one back. To change your password, please go here. Now, the developers in this case rolled out their own implementations of the session. It worked nearly the same way as requiring how the cookies will work, but resulting in several dollars spent or several money spent and made the application even less secure. So, what we have to learn from this slide is session management is very important. In this case, session management is not implemented properly, and probably in this the largest and most vulnerable point is the session IDs. But then what are sessions? It is a part of the art of session management. It is storing of data on the server for later use. So now if you have a session ID, where do I store it? In cookies, in query strings. So the session management becomes a crucial factor in the development of the application, and also you should do it in such a way that your session is not attacked. There cannot be a man in the middle attack or session hijacking or cookie poisoning. So those kind of issues have to be taken care of. So another example similar to the first one. Here enter your email address or the username, display password on screen or email password. Very insecure implementation. Then we have already discussed that HTTP is a stateless protocol. Credentials have to be passed with every request. It should use SSL for everything that requires authentication. There are session management flaws like session ID is just as good as credentials to the attacker. Session ID is typically exposed on the network, in the browser, in logs. And then beware of the side doors. That is, change my password, remember my password, forgot my password, secret question, log out, email address, credentials which are stored in plain text in database. Now those are all the side door for getting inside. What are the typical impacts or what is the typical impact of this? User accounts are compromised or user sessions are hijacked. How the attackers do it? Now the attackers or the hackers will intercept the session ID either from the cookie or the request URL. So they can replicate the session ID themselves. Now URLs are easy. They simply type it into their own browser. Cookies are tougher. But if they can write a cookie or inject the cookie into a HTTP request header, they can trick the server. So the ideal thing to do is avoid a cookieless session, avoid using homegrown authentication schemes. You have to look into the option of IP checking. Then for some cases, double check passwords on certain activities or make the user enter the password twice. Use SSL, and the most common vulnerability or the most common loopholes that these applications have is the sessions do not expire early. The timeout for the session is perpetual in some cases. Now, even during assessment of certain applications, when we escalate this to the vendor, he says the client does not want to have a session timeout. So what can I do? So this is actually a issue where the session hijacking, the cookie poisoning, all those things can happen if the sessions do not expire early and if it does not expire often. The user is just lazy to come back and retype his login and password. So he doesn't want the session to expire, which is a very bad perspective from the security. And we said avoid cookieless sessions. Say in web.config file, set cookieless equal to false. This does not completely solve the problem, but it makes the task of cracking a whole lot difficult for the attacker. Is this a good session ID generator? Now if you see on the left hand side, the session IDs are generated. And there is a pattern into this if you look at it. The pattern is on the right side, if you see the first one, the 97531. Again 97531 is repeated. Then the one next to that is fully filled with H. Then A B C D E F G H. 11111, 22222, 33333. So is it a good session ID generator? It is not, because there is a pattern which is found in the session. What is the protection for this? Authentication should be simple, it should be centralized, and it should be standardized. So use standard session ID of your container, protect credentials and session ID with SSL or TLS, keep your SSL certificate safe, automatically log out inactive sessions, never start a login process from an unencrypted page, and session IDs and credentials that don't belong into the log files. So you should never log the session ID and credentials in the log file. So these are some of the measures or protection measures